Good morning, everybody. Welcome to Middle School Algebra. My name's Michelle Belisle. I teach at Grand Bay Middle School. It's good to have you here this morning. Today we're going to talk about standard deviation and variance. Glad you all woke up and joined me this morning. If you were here with me last week, you remember that we talked about mean, median, and mode. Well, we're going to use mean again this week. Mean is when you take all of your data set, add them together, and divide by the total number that you have. The first thing that we're going to talk about today is the MAD, or the mean absolute deviation. Absolute. What does absolute mean? If you remember, absolute means absolute value. That's where you take the number, it's the distance. Absolute value. The average distance between each value and the mean. Well, when you look at it, you have to find the mean, you have to find the absolute value of the difference between each value and the mean, you have to find the sum of the values from step 2, and then you divide by the total number of values. Well, you say, Miss Belisle, that's a lot of different things to do. Sounds very confusing. Does sound very confusing, doesn't it? But if we look at what we're going to be doing, we'll break it down step by step, and it's not going to be that confusing when we do it together. So let's take some data points and let's find the mean absolute deviation of all of those data points. If we have a set of data points, if we take the numbers 17, 12, 19, 14, and 13. And if we want to find the mean absolute deviation of those data points, what's the first thing that we need to do? Well, let's go back and let's look at our steps. The first thing that we need to do is find the mean. How do we find the mean? We add those points together and we divide by the total number of points. Well, if we add those points together, 17 plus 12 plus 19 plus 14 plus 13. We add those together. I don't like this marker, so I'm going to put this marker aside. There we go. I like this type of point. And we get 75. 1, 2, 3, 4, 5 total points. 75. We divide by the total number of points, 5, and we get what? 75 divided by 5 is 15. 15 is our mean. That's our first step in finding our mean absolute deviation. Well, our next step says to find the absolute value of the difference of each value and the mean. This takes a little bit more work. So we have to go step by step with each one of the points. Let me go ahead and tell you this. If we were a statistician and we were working in our office, would we be doing this by hand? No. We'd be taking all of these values, we'd put them in a computer, in a graphing calculator, whatever. We'd let that do the work for us. So why are we doing this? Because I want you to know how to find the mean on your own, to see exactly what this means. So absolute value, what is the absolute value? It's the distance on the number line. So distance, can distance be negative? No. Distance is always a positive value. So this is what I want you to do. I want you to take your numbers and I want you to do this. I want you to say the absolute value of 17 minus 15, plus we have to add them together. So I'm going to go ahead and kind of combine steps number 2 and steps number 3. I'm going to go ahead and sum them up. Plus the absolute value of 12 minus 15. Notice I'm taking my value and I'm subtracting my mean, but I'm putting it in those absolute value bars right here. Then I'm going to add my next value. Absolute value of 19 minus my mean. Then I'm going to add the absolute value of 14 minus my mean, and then I'm going to add the absolute value of 13 minus my mean. Now, this is something that's very interesting when we're finding the absolute value, to make sure you do it correctly. What is 17 minus 15? 2. What is 12 minus 15? Negative 3. 19 minus 15 is 4. 14 minus 15 is negative 1. 13 minus 15 is negative 2. To make sure I'm doing my math correctly, these should all add up to 0. 2 and 4, those are my positive numbers, that's 6. Negative 3, negative 1, negative 2, that's negative 6. So yes, that will be 0. They cancel each other out. Positive 6, negative 6. That gives me 0, so I know I did it correctly. That's perfect. My next step tells me to divide by the number of values. So I have the absolute value of 2 plus the absolute value of negative 3 plus the absolute value of 4 plus the absolute value of negative 1 plus the absolute value of negative 2, and I'm going to divide by 5. Now we all know that absolute value is a distance, so I'm going to take my positive values of all of this and add them together. 2 plus 3 plus 4 plus 1 plus 2 divided by 5. 2 plus 3 is 5, plus 4 is 9, plus 1 is 10, plus 2 is 12. 12 divided by 5. And 12 divided by 5 is 2.4. A lot of steps, isn't it? A lot of steps, a lot of work, maybe a little bit confusing. But what did we do? Let's go back over it one more time. Absolute value. We found what's called the mean absolute deviation, MAD, MAD, mean absolute deviation of this number set. We found the mean, we added all of these numbers together, and we divided by the total numbers. 75 divided by 5 gives us 15. So what was our next step? We found the absolute value of each number. We subtracted the mean from that number, and then we found the absolute value of that. That gave us the distance of that number from the mean. 17 minus 5, 12 minus 15, 19 minus 15, 14 minus 15, and 13 minus 15. We found the absolute value to give us that distance. We added those absolute values together, divided by the total number of values. And that gave us the mean absolute value of 2.4. So when we follow these steps, step by step, we get our mean absolute deviation. Okay, that's one measure of spread. Now, these first three measures of spread that I'm going to talk about, mean absolute deviation, variance, and standard deviation, these are the measures of spread that work with normal distribution, your bell curve distribution. Okay? Symmetrical bell curve distribution, and I'll talk about that in just a little bit. If it's skewed, that's when you need to use range, and that's when you need to use interquartile range to figure out your spread. Okay? But next, I want to talk about finding let's flip this little page here. Variance. Finding the variance. Now, variance is sometimes represented by lowercase sigma. And it looks like this little 0 with a loop on the end of it, lowercase sigma squared. Okay, let's talk about variance, and let's talk about what variance means and how you find variance. Variance is how far the data varies or how far that it's spread out. If your variance is small, then that indicates that your data is close to your mean. If your variance is spread out, then our variance is high, that indicates that your data is spread out from your mean. And it's the average squared, notice it's got the exponent of 2, it's the squared distances from each point to the mean. And you will see it written as that this is a capital sigma, and it means sum. This is your data points minus your mean, all squared, not 2, divided by n, and that's your total number of data points. Now, if your population, your data points, let's talk about this real quick. There's something called population variance and there's something called sample variance. And let me make a distinction between the two things real quickly. I'm using what's called population variance. That just simply means these are the only numbers in my data. Miss Belisle's 8th grade class, I can calculate all of that and use only my numbers from my 8th grade class. But if the data set was the 8th grade classes in the United States of America, I couldn't calculate that because the data set's too large. So I would have to take a sample and use just a sample of the data. And so if that were the case, then my denominator, instead of dividing by n, I would have to divide by n minus 1. But for our purposes, we're going to use a smaller data set and divide by the total number, not an n minus 1, a sample. Just wanted to make that clarification for you guys. But now, since we have moved on past the mean absolute deviation and we're moving on to variance, let's talk about variance and let's talk about how to find variance. We're going to use this exact same data set and we're going to calculate the variance. Now we have already calculated the mean, and we said that the mean was 75 divided by 5, which was 15. Now, to find the variance, we take the sum of the data minus the mean, and we divide it by and we square it, and then we divide it by the total number of data points. So let's look at what that means. Let's go through it where it says step by step. For each data point, find the square of its distance to the mean. So let's write that out step by step. For the first one, 17 minus 15 squared, and I'm going to add to that 12 minus 15 squared. Then take the next point, 19 minus 15 squared. The next point, 14 minus 15 squared, and then add the final point, 13 minus 15 squared. Once again, my total number of data points is 5. And then all I do is I go through and I do the math. 17 minus 15 is 2, and I square it. 12 minus 15 is negative 5. 19 minus 15 is 4. 14 minus 15 is not negative 5, it's negative 1. And then 13 minus 15 is negative 2. And I'm squaring all of these differences. And I'm going to add them together, and I'm going to divide by the total number of data points. So what is 2 squared? Once again, I'm finding distances, and I'm squaring. I'm finding differences, and I'm squaring. 2 squared is 4. Negative 5 squared is what? It becomes positive when I square it, doesn't it? Negative 5 squared is 25. 4 squared is what? 16. 1 squared is 1. And then negative 2 squared is 4. And I'm going to divide by 5. When I add these together, I get 34 over 5, and that gives me 6.8. And that is my variance. So let's go over this one more time. I take my numbers in my data set, and I subtract my mean, and I square the difference. 12 minus 15 squared, 19 minus 15 squared, 14 minus 15 squared, and 13 minus 15 squared. Make sure I square those differences and then divide by the total number in my data set. And that gives me my variance. Now, once I get this, there's only one more step to do to find my standard deviation. I take this number right here in my variance, and I'm going to erase this. That 34 over 5. And I want to make sure I don't round too soon. I'm going to take this number in my variance. And I made a mistake in my math, which is very common. Ms. Belle-Isle does that. 12 minus 15 is negative 3. So that's going to be 9. But my answer on my paper, it's still 34 over 5. Sorry about that. And my students in my classroom would have their hands up going, Miss Belle-Isle, you made a mistake. So thank you for catching that mistake and letting me know. 12 minus 15 is negative 3, not negative 5. And negative 3 squared is 9. But when you add 4 and 9 and 16, because 16 and 4 is 20, 9 and 1 is 10, that makes 30, plus 4 is 34. So these do add together to 34. So thank you. And I apologize for that. But once you get the correct numbers on the board, or the correct numbers on your paper, and you get to this point with your variance, to get your standard deviation, all you have to do is take this number and find the square root. But don't take the square root too soon. If you round to get your variance, don't take the rounded number to find your standard deviation. Keep that whole number in your calculator to find your standard deviation. But this the square root of 34.5 is 2.6. Okay, luckily for us, 6.8, you don't have to round. That is the number. So that's not that big of a deal. But 34 divided by 5, square root of that is 2.6. The standard deviation is just the square root of your variance. Okay? So that's not that hard to compute. Once you find your variance, all you do is take the square root of it, and that gives you your standard deviation. Now, one thing I want to bring up real quickly is this. Something that your standard deviation will show you. Now, don't make fun of my drawing because I can't draw that well. But when you have your normal bell curve that looks something like this, like a little bell upside down, and you've got your standard deviation, this is your mean right here. %68 of your data is going to fall in this area right here within one standard deviation of your mean. Okay? Within 2 standard deviations right here, you're going to have 95% of your data. Well, I don't have another color. And then within 3, you're going to have 99.7% of your data. And that's what standard deviation is going to tell you. That's the good that standard deviation is going to tell you, the percentage of your data. But that only works when you have a normal curve. Your range, your interquartile range, will give you more information for your skewed data. So once again, I lost it. Mean absolute deviation is your distance from your mean. Absolute meaning the distance from the mean. I just lost my train of thought, dadgummit. Standard deviation, mean absolute deviation, and variance are best when you have a normal distribution. Next week, we're going to be talking about two-way tables.